let me know. All right. So, what I recommend doing is still, like, especially with these LeetCode problems, create an outline. Why? Because so much of LeetCode is seeing the problem and then knowing what kind of, obviously, like, and then knowing what kind of solution to apply to it. All right, like knowing what's the correct tool when you see this kind of problem. All right, so I'm kind of giving you some labels for it, but it's also on you to do that processing because it doesn't help if I know it and I talk about it, but you don't know it. All right, so we talked about like self joins, right? And then there's I think there was basically two use cases for our self joins that we saw. One of them was these self-referential tables, right, where we have something like, say, each employee has a manager, right, and and so we have one employee's table, but that employee table has like an ID and like a manager ID, but that manager ID just references another row's employee ID. Okay, so if we want to find like the employee's direct manager, we have to do a self join to do that. And the kind of like the key thing is when you do like something like select all from employees, you just give it an alias, right? E1, join employees, and you could do managers, right? And just give this an alias of managers, right? And then you join on, etc. Right? Employees dot ID equals managers dot manager ID, something like that. Yeah, that would work, I think. So this is one use case, right, which is our self-referential table. The other one is essentially like a window function, kind of like a window function alternative, where what we're doing is we're lining up one row from the table with like a previous row, with another row. And the way that we're doing that generally is like with a calculation, right? So we saw this with like our weather, classics like weather data, stock data, and you can imagine if I want to find like the difference between weather, it would be like select all from temperatures, T1, join temperatures, right? The same table but different alias, T2 on, and then it's T1 dot ID equals T2 dot ID plus 1 or something like that, right? Where we're saying, okay, today the 1 day from table 1 from temperatures equals actually this would be the previous day plus 1, right? If this is day 0, I'm going to confuse myself. If this is day 1, then this will be lining up with the previous day 0 plus 1 equals 1 here. All right. So that's how we can line up, right, in one row a day with like the previous day. So these were our two use cases for self joins, I think. Then the next thing we covered was cross joins. And like, remember, they're pretty easy. All we have to do is forget to put the on key, and what will we do? It's a nested loop, right? And why do we use? And really, when you're going through the outline, it's like, well, why do we use this thing? It's basically when we want to compare every row with every other row. So what are the types of problems with this? Remember, we find like the minimum differences between age, like minimum difference problems, right? Or the minimum difference between the Simpsons kids and the minimum difference between points in a line. Right? Those were our two cross joins problems. And then was there anything else we covered? The outer joins, which I feel like you got. Right? Left join, right, left outer join, right outer join, full outer join. Okay, so those were what we covered in the last class. In this class, right, what will we cover? We'll cover this correlated subqueries. So let's talk about this. Okay, so the idea, let's take a look at our employees. So we have this list of employees, and then we have the salary. So now let's say we want to add a column here that indicates the highest salary for each department. So by the way, we can do this with a window function. Like your first thought should probably be window function. But I'm going to show you a different way of doing it with a correlated subquery, and then we'll get to a use case for correlated subqueries. So here, for example, if we add this max salary column, it would be something like, we'll get HR, it'll be 52,000 here, right, and 52,000 here. And for IT, we'll get 60,000 here and 60,000 again here, and then 62,000 for finance. So the way to do this is basically you do a standard query, and we'll do select all from employees, E1, and you just immediately give it an alias, okay? And now what we'll do is we'll add another column, we'll call it max salary. I always write it out first, I don't know why. And then here we'll do the correlated subquery. So in this case, what we'll do is select all. So we want to go through each of these rows. Basically, the idea here is for every one of these rows, we want to perform another query. That's our correlated subquery. And our query here is going to go through each of these rows. So we start with this first row, go through each of the rows in the table, find the matching department, and then find that maximum salary. So I'll do it and then I'll explain it again. So we'll do select all from employees, or from employees, join E1, that's this outer table, on employees dot department equals E1 dot department, and let's say we want the max salary as the max salary. I don't even need that, I don't think. And now that will only give me one row. I think that will work, and I broke it. Let me just find what I did. No such table, E1. From employees, join E1. I may have to cheat. I apologize. Let me cheat because I don't feel like confusing you. This is it. Select employee name, department salary. Select max salaries from employees. I guess I gave it E2. That's fine. And then from employees E1. So let's just copy this and I'll explain it. Apologies for the error. So you can see this part here is just referencing the normal outer table, E1. And now for each one of these rows, HR, IT, it goes for one by one through the row. And for each one of these rows, we will join the table, call it E2, join it on the department where it equals the outer table, right? So for this guy, we're joining with all the other HRs, and then we're finding the max. Okay? I'm not actually sure what I did wrong here, except for maybe I needed to give this something here. I think that might be it. I might have needed to give this an alias. Let's see if that fixed it. And it didn't. No such table E1. That's so weird. Why is that? Join.
You have to say employees E1. It doesn't know what E1 is. Because you had to define it earlier, I think.
Oh, really? Let's see.
No, I mean like in the query.
Mm-hmm.
I have to say join employees E1, not from employee.
Join. Let's just take a look at this one. Select max salary from employees E2. Change join employees E1. But I don't do. Actually, I don't. Oh, you know what? I don't do a join here. That's the difference. That's weird. But I'm glad I know it now. So we don't do a join here. From employees E2 on E2.department equals E1.department. Let's see if that. Ah, damn it. From employees, select max salary from employees E2. Oh, where, and then I actually did a where E2.department equals E1. That worked. That's weird. Okay, so what I did was first we have this outer query, and then you don't have to reference it again, I suppose. So instead, this query performs first, and then for each one of them, we reference it, and we say, okay, we're going to select the rows where this inner queries table of E2.department equals the outer queries table of E1.department. And we can only return one row, one value here. So that's going to be our max salary. Okay. So what I was doing before was I was joining. I'd have to look up if how to do that with this, but here I'm not actually joining the table. Instead, I'm first loading this outer table, and then I'm referencing the outer table in the subquery, okay, and kind of doing a separate query where we are selecting from the employee, selecting from that same table again, and essentially lining them up. And the way to view this, like the kind of like the key thing of a correlated subquery, is it's just a loop. You're looping through all the rows of the outer query, and then for each row, you're selecting, you're kind of looping through it. You're selecting from the table, this table employees, finding where there's a match for each one of these rows. Okay? Okay, so we said we could do this with a window function. One thing you could not do with the window function, say, is let's say we want to find the second highest salary per each one. Well, we can do that, I hope, with a correlated subquery by saying, let's select the salary where E2 department equals E1 department. We can start with just like a limit 1 order by salary. So we're finding all the matching salaries for each row. I'm going to switch this just so it seems a little bit more readable. For each row in the outer table, find all the rows that match, and then order by the salary descending limit 1. That should give us the same answer, but now we can offset it. I think I can do the offset here. Offset by 1. Okay, so you see that? So this is now giving us the second highest salary. I will make it the answer more clear by ordering by the department, comma, salary descending. Yeah. So we can see the second highest salary for HR, right, is $50,000. The second highest salary for IT, right, is $55,000. So it's the same, kind of thing, because I don't know that we can really do this with a window function, but we can do this with a correlated subquery, where for each row we requery the table, find the matches, and then kind of here we're doing just give me one value back for each of the rows. Okay. Does that feel all right?
So what were you saying about, can you repeat again what you said, that why window functions aren't, why when you use a correlated subquery instead of window function?
Yeah, so with a window function, we could do this. I have kind of like the alternative, the window function here, where, with the window function, we can take like the max, partition by the department, right? Order by the salary, or we don't even have to do the order by the salary. We just take the max. I'll copy it. But that's only giving you the maximum value. Like where we have a window function that will calculate the max for each partition. But I don't know of a window function, or at least it's not.
You can use rank or dense rank over.
Yeah, but okay, if you do dense rank, right?
Yeah.
Let's try to do that. So now let's say we do like rank over partition by, and I need the parentheses here, right? Rank over partition by department. We want, or here I do probably need an order by, order by salary descending. Okay. So here, right, we have the rank, but it's not listing the salary for each one. I mean, I could now wrap this and only select those rows, right? But then I'm missing some of the rows, right? I don't have actually that second highest salary next to it for each one. So the closest I could do is kind of say like with, rank salaries as, wrap this in a CTE, select all from ranked salaries. Okay, and now where let's call this my, wherever this column equals 2. I could do that and then just remove, this column from the select statement. But that's filtering filtering my end results. This thing is still leaving all my end results. It's just giving me the second, the previous one was giving me the second highest salary. It's this one, right? This is giving me the second highest salary for each one, right? So with a window function, I can give the rank, right? I can use these like pre-given for me window functions like rank, max, but then going more kind of detailed than that, I don't know of a way to do that. Yeah. Okay. Here's something else. Here's actually I think a more powerful use case. Yeah, let's do this one. So here, I think this is I'm proud of myself for this example. So I'm going to do this one. Okay, we have dog foods, and we have customers. Okay, and now each customer has a budget. And and now we have this, and now we have the dog food price. Let's say we want to see, each customer wants to see what's the maximum amount he can spend, what's the priciest dog food he can spend that's still within his budget. This is kind of what we can do. So it's select all from customer C. So this is my outer table that I immediately give an alias. And now here is where I put in the subquery, right? I say it's as dog food price. So here now I select not from my outer table customers, but from my dog foods, okay? And instead here my where clause is where the price is less than the budget, but now I take the highest one by ordering by the price descending, right? So from highest to lowest, limit 1, and now giving my dog food price, okay? So the most that John can spend, right, is 22, because this is less than the budget, right? So here his price is less than, so the price of the dog food is within his budget, and we're ordering by to get the most expensive price he can spend. All right, here this guy can bump up higher to get to 40. This is less than or equal to, so it keeps, and this guy can bump up even further to get to 45. So notice, what I'm paying attention to right now is in both cases, like the one above and this one, we're not doing a join. I don't know if I don't know if you can, maybe you can, but we're doing instead a where clause. And that's kind of how it's like this kind of more precise join, but really it's with this where clause. We're just simply loading this second table, and we're referencing the outer table with this alias. Okay, so again, it's load the outer table, that's this stuff, and then for each one of these rows, we're going to perform a query where we select from dog foods and give me the price that's less than this budget, and now order by to get the highest one within this budget. Now go to the next one, select from dog foods, give me it within this budget, order by to get me the highest one, and keep going. All right. So that's our correlated subquery.
Hey, Jeff, are you able to reference the table that you're referencing within the correlated subquery outside the select statement? Like, for example, if you wanted the brand of the dog food?
Yeah, I think so. Yeah, I do get what you mean. Can I do select all? Well, here I have dog food price, select dog food stop price. I wonder if I could do a second one, or I doubt it. I think I'm going to have to do a second correlated subquery, is my sense.
Okay.
Right? If I put, like, dog food stop brand here, I don't think that's going to work, but let's see. Yeah, that's... Oh, I need a comma here anyway. No, that's not working. I don't think... Go ahead.
Oh, I just said okay.
Okay. Yeah, I don't think that works. Unless anyone else has another thought. Okay. So these are... So this is our correlated subquery. The way to understand it, there's a couple reasons why I give it. One, this is a nested loop. It's not always that. It's not technically always a nested loop. I give a kind of breakdown or I reference a blog post that breaks it down more detailed than that. But it's something to pay attention to with like SQL optimizations. If you see something like this, you can now understand it and kind of know some of the danger is that for each row, right, is querying the database. Again, like some databases have more optimizations than that. But then the second reason is, of course, it's like this more detailed kind of like window function / a more detailed like fine-grained join, right, that we can perform. Okay. And then the rest of the work is essentially, I have you practice the correlated subquery, so I'll let you get to that. And then the rest of it is like these gaps and islands problems, which, I'll let you, I wanted you to try it before seeing the answers with them. Okay. But, any questions about the correlated subqueries? They're good to have, again, like at your disposal. I think they can make things easier for you if you're just comfortable using them. It's also good to like see where they can go further than our joins and our window functions. And these are the main components. And I think the main thing I learned was we're using a where clause basically with it and not a join.
So
Right.
really quick, the fact that it works with a where clause and not a join, is that only the case because it's one table?
I don't know. Like, I don't know. We'd have to go further. I'd have to like
Okay.
explore it further.
Okay.
Yeah. All right. So I'll deploy this. And then actually we should talk